Hello, and this is our NASA Mars Lander final report. This is Team Red Reach Tech. So, an overview of what we're going to be going over is we have introductions first, then we have a background on the project, requirements for the project, the final design, the manufacturing, the test results, and then the conclusion. And then if you guys want to introduce yourselves,
Hello, my name's Ebony Allen.
Hi, my name's JP Doherty.
my name is Andrew Kravchuk.
My name is Daniel Trio.
Okay, so the background request for proposals, this is basically outlining what our project's supposed to be able to do, or yeah. So it's just skimming over it. It's just we have to build a vehicle in order to land on the Mars, and it has to be carrying two pilots, and it has to be launched twice to show it's reusable. And so in the phase one, we asked the customer what they wanted for the vehicle, and they said that we should deliver the astronauts to the surface of Mars. It should be demonstrated with video recordings on launch day. The launcher should carry two pilots, and it should be reusable. And then what we came up with, our requirements, is that it should survive an impact of 12-foot drop. It should protect two eggs, and they're about 59 grams each. It must be reusable at least two times. The pilot should be able to enter and leave the cockpit in under 1 minute, and the maximum budget should be $15 or less. And then obviously the last one, the lander should be built in under an hour and a half. So during our class time.
Okay, so now I'm going to be talking about our final design that we selected. The drawing from the top, from the front, and from the side. From the top, you can see there are four plastic bags. Those are the red circles right there. And also from the top, you can see the two eggs inside the styrofoam box that we made. The styrofoam box, we had 1 foot, 1 square foot, but we decided to cut it into a smaller piece. From the front, you can see not only the paper balls, you can also see the cotton, and you can see the plastic bags working as a parachute a lot better. The same thing from the side. Now, for our charges and our total cost, we our materials were tape, scissors, and cutters. That's first thing, but that's the first thing that was provided to us, so that didn't cost anything. But we did have to buy the paper sheets. We bought 20 of them, which in total was $2. We also bought 1 square foot of styrofoam, which in total would be $3. We also bought 1 square foot of bubble wrap. We only bought one, so that's $2 added to it. We also bought one set of four plastic grocery bags, is adding $1 to it. And for the cotton balls, we bought 20 cotton balls, so that would be a total of $1. And that if we add it all up, that would be $9 total. Now, as you can see our picture, you can see the four plastic bags, the tape, the scissors, and the ruler that was provided to us. You can see where the paper, you can see the 1 square foot of bubble wrap and the styrofoam and the cotton balls, which I will describe later how we used everything. Now, for our construction plan, our first step was to cut the styrofoam into a box. What we did first was take a piece of styrofoam from the square foot, and we taped it to the other piece that we had cut open to make an entire box, but make it smaller. Then what we did was we flipped the box upside down. We spread out the cotton balls. We didn't tape them together, but what we did was we taped them with the tape going all the way around them, so we didn't waste as much tape as we would have. Then we repeated the last step, but instead of using more cotton balls, we used the paper balls. That went on top of the cotton balls. Then we put the bubble wrap on top of the paper balls, and after we did that, we put tape all around the bubble wrap to make sure it stayed put. After that, we attached the plastic bags by rolling the handle of it. We taped them in the edges of the box, and we just inserted the remaining cotton balls into the egg chambers wherever our two pilots were going to be in. And after that, we just put two paper balls, the ones that we had missing laying around, just on top of the eggs to make sure they didn't fall off.
I will discuss the construction plan. Some changes we made. Not including, wait, we did not place the cotton balls on the side of the vehicle, and we added a styrofoam between the eggs, and we had to use paper balls to secure the eggs inside of the vehicle. One changes we faced during the construction was trying to figure out how to keep the eggs securely inside the vehicle since the top was open. This is our Mars lander vehicle shown from the top view, in the side view, and the front view. Here's our details of our lander vehicles and test results. The dimensions was the length was 16.5 centimeters, the width was 13 centimeters, and the height was 16 centimeters. The first drop, it took 20 seconds to load the pilot and 9.9 seconds to unload the pilot. The second drop, it took 16.97 seconds to load the pilots, and it took 9.5 seconds to unload the pilot.
So in these two videos, it'll be showing us the videos of our actual Land Rover going in action. In the first test, you'll see that we had a small malfunction in our egg containment. So the piece of paper did fall out. We were a little bit hesitant because we thought that was the egg itself, but it ended up just being a piece of paper. But that is something that we could improve on our later design. But the second result was much better. It came down with no issues, and it landed pretty softly, and both eggs were really unharmed. Um, both results were very optimal. That's exactly what we hoped for. And in the next slide, it'll show us exactly the results of both our vehicles and the pilots. So as you can see, both pilots on the left-hand side were unharmed, no cracks, anything, and our vehicle was relatively also unharmed. There was no any outstanding damages or any damages at all, except for the fact that one of the papers fell out. On the second test, also again, both eggs of pilots were okay, and our vehicle landed perfectly fine, no damages at all. Everything was structurally sound, and we had a successful two test.
So the conclusions that we took away from this project. So the design overall, it used instead of one parachute, it used four parachutes, and that was to ensure the stability of the project of the lander. And we placed them at each corner to make sure that it would land in the center. And the assembly was really easy because the styrofoam that we already found from the recyclable materials was already in a roughly square shape. So it was easy to attach all of the parts to it and cut it out to the parts that we needed. Additionally, we had a little challenge with how to keep the eggs in and how to tape the cushioning material onto the bottom to pad the landing. And eventually we decided that we just tape over the materials and then ensure it keeps it in by putting bubble wrap in two directions over it. And of course, the eggs being open, we solved that with placing paper on top of the eggs to make sure they didn't fall out. And then the test results were really good since none of our pilots were damaged and the vehicle was untouched practically. And then some redesigns that can be implemented are to create a safer point of entry for the eggs and to hold more eggs or to hold the eggs inside the vehicle. So it's just again reiterating that the paper ball method was mostly a temporary solution, although it worked, it could be improved upon on a redesign. And then again, the first trial almost had a fatal accident in where the paper ball popped out, but the egg stayed inside the chamber. And this could have resulted in a damaged egg. Thank you so much.